Computer science videos here today to show you guys in this tutorial of operating system concepts. Part 1, the overview. Chapter 1, introduction, computer system organization, storage structure, and now we can say the wide variety of storage systems can be organized into a hierarchy, which I will now be drawing for you on screen. So the storage device hierarchy. Which starts from the bottom, which is magnetic tapes. And then goes to optical disc, to magnetic disc, to then SSD, solid state disk, to then the main memory, to then the cache, to then the registers on top. We'll just say R for register, and then we have the arrows pointing up, 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 all the way to down. And so with this diagram of the storage device hierarchy, we can say the higher levels are very expensive, but they are fast. Yes. As we move down the hierarchy, the cost per bit generally decreases, whereas the access time generally increases. The trade-off is reasonable if a given storage system were both faster and less expensive than another. Other properties being the same, then there would be no reason to use the slower, more expensive memory. In fact, many early storage systems, including paper tape and core memories, are relegated to museums now that magnetic tape and semiconductor memory have become faster and cheaper. The top 4 levels, all cache, main memory, solid state disk, may be constructed using the semiconductor memory, which is either volatile or non-volatile. As mentioned earlier, volatile storage loses its contents when the power of the device is removed. In absence of expensive battery and generator backup systems, data must be written to non-volatile storage for safekeeping. In the hierarchy shown in this diagram that we have drawn on screen, the storage systems above the solid state disk, which is here, all the storage systems, they are volatile, whereas those including the solid state disk and below are non-volatile. So all these are just non-volatile. All these on top are very volatile. Solid state disks have several variants, but in general are faster than magnetic disks and are non-volatile. One type of solid state disk sources or stores data in large DRAM array during normal operation, but can also contain a hidden magnetic HD hard disk, and a battery for backup power. If external power is interrupted, this SSD controller copies the data from RAM to the magnetic disk, which is on bottom. When external power is restored, the controller copies the data back into the RAM. Another form of SSD is flash memory, which is popular in cameras, PDAs, in robots, and increasingly for storage on general purpose computers. Flash memory is slower than DRAM but needs no power to retain its content. Another form of non-volatile storage is NVRAM, which is DRAM with battery backup power. This memory can be faster as DRAM and is non-volatile. That's it for this video. I'll see you guys on my next tutorial. Thanks for now.